Hello, everyone. We are a team of researchers from Purdue University, West Lafayette, Indiana, United States. And I am Ramyani, and there's Dr. Elwakil and Dr. Jiang alongside me as we present this topic on the MAP, the Modeling and Prediction Platform, a versatile platform for predictive algorithms in construction and beyond. So, North America's construction industry is a very large industry. It employs a lot of people. It's very fast-paced and very dynamic. However, it is, compared to other industries, slightly slower when it comes to incorporating and adopting new technologies such as AI. And however, larger firms in the United States and also in Canada has already started to use AI for prediction and other data analysis, such as by using historical project data, which they have in tons. They can try and find algorithms that help them predict whether any problem might crop up in the future or in the current project that they're working on, because they might have similarities with other projects in the past that's harder for us human beings to understand whether there is a pattern there. And similarly, companies are using many kind of robots for offsite and on-site production and like construction work that you can see in the two images on the right-hand side of the slide, alongside digital twins, which is very popular right now, which is the bottom left image on the slide. And however, smaller firms and medium-sized firms which have budget constraints can often face resource issues and expertise barriers because even though they want to incorporate such things, they just don't have the resources to do so. So for this study, our proposed solution is to have a platform for non-experts. So the MAP, which stands for Modeling and Prediction Platform, can give smaller and medium-sized companies the opportunity to access certain patterns that can usually be figured out by companies which have a lot more funding than them because they have the resources to put into this kind of work. And it can help smaller and mid-sized companies to be smarter about the kind of projects they take on, the kind of projects they're planning, using their company data to improve any kind of estimation like cost estimation, time delays. And also it can help them create more accurate bids. And also, since we have to assume that not all firms are going to have a lot of experts and ML and AI experts to work on them, the UI or the user interface of the app needs to be very easy to understand, and so that all kinds of firms, all kinds of employees can work with their data. So as you can see from figure 4 on this slide, the MLP has a very easy to understand user interface, very intuitive. You can figure out what you're trying to do without any tutorial and whatnot. So in the first box on the top left, we can incorporate and upload our data set, basically the CSV file, and the other two boxes, it helps you figure out which variables you want to use for the input and which one is going to be your output. And the list on the right, as you can see, the 6 algorithms that we have here, these are the ones that were currently um, incorporated in MAP at the time of submission of this paper. Right now, it looks a little more different because it has a few more options, and the UI has undergone a bit of change because we are constantly working on it. And the best part is that it's completely adaptable and customizable. So depending on what kind of algorithms you want, what kind of data sets you have, you can make changes on the right-hand side very easily. And the UI really helps all kinds of users from all kinds of tech or non-tech backgrounds to choose what kind of models you have and what kind of data sets you want to use for the prediction. So on this slide, we have some preliminary, very early test results from MAP. So the output of MAP is basically these two graphs, the error histograms, so that you understand how accurate or how good results are. And the right side is the actual versus predicted for your output variable. On this slide, you can see that none of the graphs look very good. So this is a very early test data set. So as you can see, the error histogram is all over the place, and the actual versus predicted for the test variable does not look very good. So I put this in so that we can see how our app also kind of progressed. And since submission, we have worked on it also a lot because so the output looks a little different now. So this slide shows you the output that's also in our paper when we submitted it. And the next slide, here we can see that the results look better than the previous slide. The error histogram makes a lot more sense. It's very centered around zero, and our actual versus predicted graph is actually not too bad compared to the previous slide. So this is for a different data set, which was about environmental conditions, and temperature was the output variable. And as you can see, the graph on the right looks a lot more promising, and our algorithms worked better for this kind of data set than the previous version that you saw in the slide before this. So right now our platform looks even more different from what it looks like in the previous slide. So as you can see, this is the SVM algorithm that we have used for another test data set, which is actually about credit history of a really large data set of people. And this data set was about trying to predict whether somebody would default in their loan payment or whether they would be able to pay it off, depending on what kind of credit history they have, all kinds of variables in there. So we tried to test that kind of data set with an algorithm in our MAP, and the results were not too bad. And we are still currently working on this and trying to test it out with different kinds of data sets all over the industry and also like beyond the industry so that this app can be easily used by people outside of construction, and which is why we're testing all kinds of data sets, really. And also, we are constantly working behind the scenes to make sure that our algorithms make sense and whether we can improve it and fine-tune it so that we have better output. So here, as you can see, the predicted versus actual is getting better. So while there's still a bit of skepticism about new technologies in the industry and beyond, it is extremely beneficial. And right now, in order to get greener and better projects, I think adopting AI is almost a strategic thing. It's not really an option anymore because all kinds of companies, small to large size, are trying to incorporate that as much as they can in their office work, their field work, you name it. AI is always there. So what we present here is the platform MAP, which has a very simple and easy to understand platform that can easily be changed and adapted depending on what you want. You can remove and add more algorithms. Like right now, we have almost 10 algorithms, although at the time of submission, our screenshot from MAP has only 6. And the interface is very easy to learn, easy to understand, very intuitive, and even without a technical background, you can easily use it. And all kinds of algorithms are incorporated in the MAP, which would mean that you can handle different kinds of pattern recognition, different kinds of database issues, and yeah, it can work across different types of data sets. And beyond the industry, also, you can use other types of data sets that are not exactly construction based. And so we are still trying to figure out how to incorporate even more algorithms. And also, we are constantly testing and refining our code and trying to make sure that MAP really has the kind of data visuals that will help our industry move forward. Thank you so much for the opportunity to present here before you, and our contact details are here, so please do reach out to all of us if you have any questions about our study. And in the next slide, I also have some selected references from our work, and the entire list is there in the paper, so you are welcome to go through the whole thing if you're interested. Thank you so much.